टाइम है बहुत. ओके, तो आई विल मेक श्योर कि मैं समराइज करूँ चीज़ों को rather than elaborating everything in detail. And I must choose the topics कि मैं बिल्कुल तुम्हें वो कॉन्क्रीट चीज़ बताऊँ, बिल्कुल मिनिमम से मिनिमम चीज़ बताऊँ, जिससे कि तुम्हारा बाकी का आगे का जानना आसान हो जाए. ओके, तो you would have heard qubit.
Yes.
Qubit. Qubit is quantum bit basically. Qubit. Quantum bit basically. Bit is 0 and 1. Same goes with qubit, 0 and 1. But then here you have a 0 and you have a 1. These two are called as 0 cat, 1 cat. Okay? What does it mean? What is a cat? A cat is a vector. What's a cat? A cat is a vector. Here they are two-dimensional vector. 2D vector basically. So I could write it better as 2D vector. A qubit is a 2D vector. This 0 here is a 2D vector. This 1 here is a 2D vector. If it's 2D vector, then I have to have two elements inside this bracket. So I say 0 is what?
1 and 0.
1 0, and this 1
0
is
0
0. This is enough to see they are two-dimensional vector. Okay? How do you relate this to why this has to be 2D? Because this represents a two-level system. Okay. Anyway. Okay. A qubit, then we say, is a superposition of 0 and 1. Are you familiar with the idea of superposition?
Yeah, normally we know that it is.
Yeah.
There is a chance of. There is a maximum chance of. It may be 0, it may be 1.
It may be 0, maybe 1. So let's say with alpha square chance it is 0 and with beta square chance it is 1. Okay, then my qubit state is psi. Okay, so this is the most general form of a qubit. Psi equals to alpha 0 plus beta 1. This alpha and beta here are complex numbers. They belong to the set of complex numbers. You are familiar with this notation? Belongs to. They belong to. So there could be then alpha star and beta star as well. If they are complex number, then their conjugate exists.
Okay.
Right?
Conjugate, yeah.
Okay. How do I see the conjugates? If I take the bra of this cat. What do I mean by the bra of this cat? That is something like this. If this is cat and this looks like this, then its bra is going to look like alpha star 0 plus beta star 1.
And alpha star is a notation of alpha. Oh, conjugate of alpha.
Yeah. So basically, the conjugate of 0 cat is 0 bra.
Yeah.
Reverse by other way around. The conjugate of 0 bra is 0 cat. The conjugate of cat 1 is bra 1. Reverse as well. And alpha's conjugate is alpha star, beta conjugate is beta star, and you know this relation that alpha into alpha star is gonna be alpha mod square. Beta into beta star is gonna be beta mod square. Okay, this is clear. Now, what happens if I take this? Let's just try to figure out. Okay, we know this thing, right?
Yeah.
This. Then we know this thing. Then, how to calculate this? This thing is alpha star 0 plus beta star 1 with alpha 0
plus beta 1.
plus beta 1. Next step, how would this look? this with this, this with this, this with this, this with this. Okay, so I'll get 4 terms here. Alpha star alpha 0 0 plus alpha star beta 0 1 plus beta star alpha 1 0 plus beta star beta 1 1. Okay, this will give me this thing and this thing. I can replace by alpha mod square and beta mod square, right? Okay. Alpha mod square 0 0 plus alpha star beta 0 1 plus beta star alpha 1 0 plus beta mod square 1 1. Take 1 minute to just digest this part, how I have calculated. Try to reach to that last portion. It's clear enough?
Yes.
So, I never told you, right, what I am doing here. Whether it is a normal multiplication, whether it is a dot product, it is a cross product. Have I told you anything? No. I have simply just clubbed this bra with this cat in it. So I am just doing this clubbing. Okay. I'll mention you in detail later. Okay. For the time you know how to calculate this thing. Okay. Now, how to simplify this thing? What is the next step? The next step is this. AB is going to be 1 if A equals to B, otherwise 0. Okay. If A and B are same, then it's 1. If they're different, it's 0. This property is otherwise called as, any idea? Orthogonality. And this thing is also represented as delta AB. Familiar with this notation? Delta AB, conical delta. This thing basically holds a value of 1 when this A and B are same, and it holds the value 0 when they are different. Okay? समझ आ रहा है? पूरा अभी तक कोई क्वेश्चन तो नहीं है? ठीक है. Now, so ये कितना होगा? 1. ये समझ में आ रहा है? तो इसको काट देता हूँ मैं, ये 0 है. इसको काट देता हूँ मैं, ये 0 है, क्योंकि ये तो एक नंबर है. These are numbers, right? Numbers multiplied with a number is, if any one of them is 0, then there's 0. And finally, what do I get? Alpha mod square plus beta mod square. Okay? This much you have done in your copy? Just try to just compute this thing. All I have. Yeah. Now, so I'll erase the intermediate portion. Okay. So this thing, a bra clubbed with a cat is called as an inner product. Which is going to be a number. The result of which is a number. What kind of number?
Complex number.
A complex number. Okay? What is the general rule of calculating this inner product? I showed you in terms of this just clubbing अल्फा बीटा ले आओ, सॉरी ब्रा है उसके बगल में कैट ले आओ, ठीक है, फिर ब्रा कैट जितने भी हैं सारे कॉम्बिनेशन को जोड़ दो, ठीक है। अब हम दूसरा तरीका देखेंगे, ठीक है। बेसिकली हम क्या कर रहे हैं, इनर प्रोडक्ट कर रहे हैं, ठीक है। आई वुड लाइक टू मेंशन हियर दैट अगर मेरे पास ये होता a cat then a bra then it is a outer product, ठीक है। And this gives a matrix, इतना क्लियर है। इनर प्रोडक्ट आउटर प्रोडक्ट, इनर प्रोडक्ट हुआ तो एक नंबर होगा एंड आउटर प्रोडक्ट हुआ तो इज गोना बी
मैट्रिक्स,
a matrix. All right. Next. So we saw that if my alpha is this, then this inner product is giving me
complex.
So if alpha is this, then this inner product is alpha mod square 0. Sorry, alpha mod square plus beta mod square. Cool. Okay. Now see. This is a state. This is the more common. This is the general. This is the general form of a qubit, and this form is nothing but a state. This is the general state of a qubit. Okay. Again, the notion of states. What do I call a state basically? A classical state could be something with a particular position and a particular momentum that defines a state. Let's say. Okay, let's not go to that side of it. For the time being, you just understand that this is a state. Again, in different contexts, it would take maybe some philosophy, some math would come. Okay. Anyway, so this is a state. Okay, and a state is represented by a cat, which is nothing but a vector. Okay, I would say why is the vector and how do you compute it? But for the timing, this is the state. Now, every quantum mechanical state has a property. What?
Bra is also a state.
Bra is also a state.
So you were saying that that this is the normal state of normal general cubic state, and the bra.
Yeah, that is also.
That is also.
Yeah, this is just equivalent to that.
Just equivalent.
It's a mapping, right?
Yeah, yeah.
You just have to take the conjugate. Okay.
Yeah.
Yeah, because in order to know this, you have to know alpha and beta. When you know alpha and beta, you know alpha star and beta star as well.
Yeah.
Right? So it makes sense. Cool.
Cool.
Yeah. So what I was telling, what was I telling? I forgot. Okay. So this is a state, quantum mechanical state. Every quantum mechanical state has this property, the property of normalization. Have you have one? Have you studied quantum mechanics basics? Okay. So normalization. Yeah. So how to show the normalization of this state?
When alpha square plus alpha square mod alpha का mod का square plus beta mod का square equal to 1
Equals to 1. Yeah. So this thing has to be 1. Okay?
उसमें भी इतना conjugate that is conjugate actually prime theta are conjugates
Okay. Now I'll tell you how does this inner product and outer product look in terms of vectors. Okay. You wrote this property of orthogonality.
Yes.
This is very important. Okay. So, as I mentioned you, this 1 is 1 0. Sorry, 0 is 1 0. 1 is 0 1. So, the general rule is, if I have two vector, let's say two states, let's say psi 1 and psi 2, where psi1 is my AB and psi2 is my CD, and if I have to compute psi1, psi2, then it is going to be, this would give me my psi1 graph as A star, B star, this. So the transpose of this matrix or this vector with each element conjugated. Conjugate plus transpose. Conjugate by star and transpose मैंने कर लिया है.
Yes.
Clear? Same. Psi2 would be what? Tell me quickly.
C star, D star.
C star,
D star.
D star. Okay. Now we have to do this thing. This thing would be psi1 क्या है?
A star,
A
B
star.
star,
A star, B star. psi2 क्या है?
C star, D star.
C star, D star.
Yeah.
And you can do this multiplication. Why? This is my 1 cross 2. This is
2 cross 1.
2 cross 1.
Yeah, 1 cross 1.
Okay. Then you get a 1 cross 1, which is a number.
Number.
As we would have imagined, because we are taking inner product. I have already told you that inner product has to be a number. Okay. So this is gonna be A star C star plus
B star, D star.
D star. Correct?
Yeah.
A star, C star.
No.
No.
No, there should be
One
4
column
terms.
and 1 row.
Yeah.
Yeah, maybe with the 1 column and 1 row.
Just the
A star, C star, and B star, D star.
That's right.
Same.
It's correct, right?
Same.
That's right.
It's the system plus D star, D star.
This is
All term will be in vector product.
ये
In vector product that will be
Okay.
2 by 2.
Here this C won't be there, no? The C star won't be there. Psi 2 no. Psi 2 ket is C and D, right?
Yeah.
Clear?
Yes.
Have I done anything wrong?
No?
No,
Okay?
Psi to C.
Alright. Now, see. Let's calculate 0, 1, 1, 0, 0, 0, 1, 1. Okay, we have to compute this 4. Can you tell me the result without computing, just by seeing the board? What is going to be the result of this? Just look at this 4, nowhere else. Remember, before writing this, there was something written here. The orthogonality. What does it say? If they are same,
Direct.
huh?
Directly.
Yeah.
0,
0,
0,
0,
1,
1, 0, 0 and 1.
Yeah. This is going to be
0,
0. This is
0,
0,
1,
1,
and 1.
1. So this has to be the result. Okay?
Mm.
Let's try to get them by that formula. Okay? So 0 bra is what? 1 0.
1 0.
This is
0.
0 1. 1 0 0 plus 0 1. Cool? Do the rest 3 quickly. Get in the bottle. All the 4 could be proved, right? So you got the idea of how to compute a inner product. Okay, let's just do the outer product. Okay. So the outer product is going to be a matrix, right? Let's see. So let's calculate 0, 0 first. Okay. How would it look? 0 is 1, 0. 0 is 0, 1. Sorry.
1 0.
1, 0. Okay. So this is a 2 cross
1.
1. This is a
1 cross 2. 1 cross 2.
1 cross 2. So
2 by
ultimately the result is going to be a
2 by 2.
2 cross 2 matrix. Okay. Compute it and find out this.
1 0 0
Okay. Now find out these three. Do them and try to get this result by your own. Okay. Let me know if I go a bit faster. Take your time in doing the calculation, no problem. सबका निकल गया? Okay. Now, so you have computed 4 outer products here, and you have obtained 4 matrices, right? Okay. So you got the idea how to calculate the outer product. Now, out of this 4, if you add any 2, you get an identity matrix. Which 2 are they?
First and last, and second and third.
Second and third would not result in identity matrix.
They will. Yeah. They will.
This is not
They will
identity
not.
matrix, no?
Yeah, they will not.
Okay. So which 2?
First and
First and last.
First and
last.
first and last. So 0 0 plus 1 1 gives me a identity matrix of 2 cross 2. So I just write it I2. Write this result. This is very, very important. I would later on tell you why it is important and all. Do not just write it, add them. Write these 2 matrices. Okay, in a single line. Do this. Just for the sake of completion. Alright. When I am explaining you things, it might so happen that कभी मैं इधर का कभी मैं उधर का बता दूं, ठीक है? Because there is no structure in my mind that I have to follow, right? But anyway, whatever I tell you, I make sure that I make it in a coherent manner ताकि तुम connect कर सको और तुम्हारा कुछ धुंधला ना रह जाए दिमाग में. ओके. एक पॉइंट नोट करना. A state is a vector, whereas an operator is a matrix. एक वेक्टर भी एक मैट्रिक्स ही होता है, लेकिन फिर भी तुम पता कर सकते हो वेक्टर कौन सा है, मैट्रिक्स कौन सा है. स्टेट एक वेक्टर होता है, लेकिन ऑपरेटर एक मैट्रिक्स होता है. ठीक है. अब suppose there is a matrix, some matrix A, which acts on a vector AB and gives you the same vector multiplied with a constant. Yeah. This kind of equation is called as, try to recall from your linear algebra. This is an eigenvalue equation.
Yeah.
Eigenvalue equation. Okay. This eigenvalue equation. This here eigenvalue. This is my eigen vector, and this is the operator. Not eigen operator, just operator. Okay. So these eigenvectors and eigenvalues are of this operator. ठीक है. Operator has certain eigenvalues and certain eigenvectors. I'm not going to tell you how to calculate eigenvalues and eigenvectors. It is your job. I believe you would have studied it and forgotten it as well. So do revise it. Okay. Now, why did I mention you this thing? I mentioned you for a very particular reason. In quantum mechanics, what happens? You have an operator, a matrix that acts on a state to give you some number times the same state. This is the usual process of quantum mechanics. There would be an operator which would be acting on a quantum state, then it would be giving you the eigenvalue times that quantum state. So here we call it as eigencat, because this is a cat, no? Okay? This is my eigenvalue, same. This is same the eigencat and this is the operator. One particular example would be a Hamiltonian operator acting on a state gives you the eigenvalue, let's say E times the same thing. And this value here is my what? Eigenenergy. And this is my eigencat. And this is my Hamiltonian. We know that Hamiltonian's eigenvalues are nothing but your energy. That's why I call them eigenenergy. And this is what? This equation has got a very famous name, right? Whoever tells the name, I'm going to definitely give him a 5-star tomorrow. And if you're not able to tell it to me in 10 seconds, you all are going to give me one Kit Kat. 1, 2. The name of this equation, you better shut up.
Okay.
1, 2, 3, 4, 5, 6, 6.5, 7. Oh yes. याद करो अपने क्वांटम मैकेनिक्स जो जो देखे हो, वो कुछ कुछ था, क्या क्या फेमस था वहाँ पे, सब चीज़ यहाँ पे सब चीज़ 9.2 9.4 9.6 पूरी की पूरी क्वांटम मैकेनिक्स एक जगह से शुरू होती है। 9.8 एक इक्वेशन से। 10 दिस इज द स्क्रॉडिंगर इक्वेशन। I am very particular about deals, so you better give me one Schrodinger equation. Okay. I don't know in which form you have seen it. You have seen Schrodinger equation, right? Definitely.
Yes.
You have seen either in chemistry or 11th class में भी देखा होगा atomic structure में। State के ऊपर operator act करता है और फिर आइगन वैल्यू देता है। This is the Schrodinger equation. ठीक है। Perhaps you would have seen इसका जो H को particularly जो लिखा जाता है फॉर्म में, ठीक है, फिर E को जो पर्टिकुलर फॉर्म में लिखा जाएगा
एनर्जी ऑपरेटर एंड मोमेंटम ऑपरेटर।
हाँ, लेकिन व्हाट इज द बेसिक चीज? हैमिल्टोनियन ऑपरेटर।
हैमिल्टोनियन एनर्जी ऑपरेटर।
यस, Hamiltonian is in classical mechanics. It's your kinetic energy plus potential energy operator.
Yeah.
ठीक है। Anyway, just to give you the example that it's going to be an operator acting on a state, giving the eigen value of that operator plus multiplied with this state back. Okay. This is not a. Suppose A is an operator acting on A gives me some B. This is not the eigenvalue equation. It is not returning in the same vector A. Getting my point?
Yeah.
This is a eigenvalue equation with eigenvalue 1.
Same.
Cool. This is just a
Then
normal operator equation.
A is identity operator.
No, A is some any operator.
No,
Any-
like in second equation.
A, yeah, it has to be if it is doing nothing then. Right? Okay. Alright. So, an operator acts on a state to gives you another state. In general, if it is the same state, then it is the eigenvalue equation, and whatever coefficient comes here, that's going to be your eigenvalue. Okay. Now, let's see the famous operators. Okay, let's get into quantum computation business. Okay. First operator, which is sigma x. Operators are usually denoted by this hat, okay, but then many a times they are even not put, just for the sake that everybody would understand anyway. This operator, what does it do basically? If x acts on a 0, then it gives me 1. If it acts on a 1, then it gives me 0. Okay?
But it's in the state like 0 and 1, they are different matrix.
Yeah, so I gave you the example now. An operator acting on a state A to giving you B. This is not eigenvalue equation. But then an operator acts on a vector to give you another vector. An operator acts on a cat to give you another cat. Any question?
No.
You seem to be not satisfied. Ask me.
Actually, I don't get your point.
See, a matrix, when act on a vector, suppose it is a 2 cross 2, it is a 2 cross 1, then you will get a 2 cross 1 vector, right?
2
Is
plus
the-
1.
Is there any guarantee that this vector and this vector are going to be same?
No.
Only when this is the eigen equation. Okay, only when this is the eigenvector of this matrix. Okay, otherwise in general they are different. In general they are different. Getting my point? So a matrix acting on a vector giving another vector. Same here. A matrix acting on a vector giving a vector.
Okay.
Got it? Now I'll tell you what is the structure of that X. Okay?
Yeah.
Got my point?
Yeah.
Okay. So these zeros and ones are bits, right? And in our language they are quantum bits, right? And the 0 is changed to 1 by X and the 1 is changed to 0 by X. So a better, word for it would be a flipping operator.
Flipping operator.
So this is a bit flip operator. Okay.
It's a gate.
Yeah, it's a gate. Later on I would go to gate, then you can directly connect it. For the time being I am just dealing with the matrix. A matrix is a gate basically. ठीक है. A gate, what does it do? It operates. And which thing operates? A matrix operates. Basically a gate operates on a state. A gate एक तार जाली वाला गेट बना देता हूँ. ठीक है, कुंडी में ना, समझ लेना तुम. ठीक है, a gate operate on a state to give you another state. So a gate better be a matrix. And a state is any, you know.
That is also a matrix.
Yeah, but it's a more particular matrix which we know as vector. Thing is, matrix with a single column is a vector, isn't it? This is a vector, right? 1, 0, 0.
Yeah.
3-dimensional vector. 1, 0. 2-dimensional vector. If it is a number,
They have either row or either column.
3 rows, 1 column.
Yeah, like vector only have rows or column. They will not have row as well as column. Like they can't be 2 into 2, 3 into 3.
Yeah. So they basically have rows. Yeah, or column. As in
Or
this.
column and or row.
इसका अगर ब्रा निकालूं तो ठीक है. इसका ब्रा निकालूं तो क्या हो जाएगा? 1, 0, 0. अगर ये I हो जाता तो माइनस I
Minus.
0, 0. समझे? क्यों? क्योंकि वो conjugate हो जाएगा. ठीक है. Okay. Let's come back to our business. So X, what is the structure of 0?
1 0
1 0 gives me
0
0 1 and X acts on 0 1 to gives me
1
to give me 1 0. Okay, so how does this matrix look? वही हमें देखना. Okay, let's try to construct it. Okay. That means A acting on 1, sorry, A 0, so A plus 0, C
plus 0.
This means A equals to 0, C equals to 1.
Yeah.
Similarly, find out B and D.
They will have 1 and 0.
B would be how much?
1.
1 and D would be
0.
clear, right? So my X now is, what is here?
0
0
1 1 1 0 0.
This is my x. Okay. Cool. Now try to compute this 0 1. एक रिवर्स कैलकुलेशन करके देख लेते हैं. इसको एक बार इसके ऊपर ऐड करा के देखो और एक बार इसके ऊपर ऐड करा के देखो. देखोगे तो मैं ये मिल रहा है कि नहीं. Getting right? Anmol?
Yeah.
Any idea where is the old marker?
No, I don't have any idea. It's there on the table, I suppose.
Okay. I wanted to fill ink in it though. Okay. It's coming, right? Okay. So sigma x or x is 1 1. Okay. This is bit flip operator. Otherwise, it is called as a NOT gate. नॉट ऑपरेटर क्या करता है? 0 को 1 बनाता है, 1 को 0. ठीक है, तो दिस इज अ नॉट गेट एज वेल. ओके. Okay. Now let's talk about Z gate or Z gate, whichever way you pronounce it. So I tell you that my Z gate when operate on 0 gives me 0, but then when it operates on 1 it gives me a -1. With the same formalism, taking ABCD and solving the equation, माने कि ABCD
and
acting on 1 0
1
giving me 1 0 and ABCD acting on
0
0 1 giving me minus of 0 1. Okay,
Just
compute it.
how should I write?
Compute the matrix.
ऐसे ही सेट करते हैं ना विकिपीडिया टाइटल एंड URL और डेट एक्सेस.
अच्छा, tell me this though. Y acting on 0 gives me what?
Minus I मिलता है, I think.
Minus I?
Minus I and Y acting
No,
on
minus I one.
Do not confuse me. If you are correct, then
Minus I cat of 1.
it was the same
Yeah.
thing. It was the same thing. Minus I cat of 1.
And I get 0.
Sure?
हाँ.
Okay, ठीक.
Thanks, sir. I know.
इसमें नहीं कर रहा मैं.
Sigma Y is बोलो.
0 iota
Minus
iota
iota.
0.
Good. Okay. अब मैं बता रहा हूँ द मोस्ट इम्पॉर्टेंट गेट मतलब लिटरली मोस्ट इम्पॉर्टेंट गेट. उसके बिना क्वांटम कंप्यूटिंग खत्म है. वो क्या करता है? What that guy do? He takes a 0 to a combination of 0 and 1 and 1 to a combination of
0 minus 1
that gate is called as Hadamard gate. Find out its structure. पॉज
That type of
सर्किट क्यों मिलाएंगे ओके तो कैसे करोगे द सेम टेक्निक
Yeah.
इसका वेक्टर निकालो पहले
okay.
इसका वेक्टर निकालो पहले डू द सेम एबीसीडी फॉर्मुलिज्म ठीक है चल
After 2 years, मैंने मैथ लैब में कर दिया आज.
Hey, even I want it. What you are?
ठीक है, 2018 का वर्जन डाउनलोड किया है.
The thing is, I have a MATLAB, but I'm not able to crack it. You have to do that for.
Yeah,
do that
cracked
for.
version ना.
You crack your own software.
I'm not able to crack it.
Thank you so much, brother. कसम से तुम आ गए तो भगवान स्वर्ग का सबसे ऊंचा स्थान तेरे को ही देगा.
क्रॉस चेक करो
इसका नाम इसको ऐसा लिख सकते हैं.
अरे ना मल्टीप्लिकेशन में आ रहा है.
ये लिख सकते हैं. 1 yes. क्रॉस चेक करते हैं तो
do you remember where is the ink
नहीं मैं second time you are asking me this.
1 and a -1.
that's it nothing else
1 by root 2.
so the most important gate which is otherwise called as Hadamard gate is 1 by root 2 बोलो
1 minus 1.
okay one last gate. There are many gates, but one last gate. That is what that gate do basically. Let me name that gate as a C gate. It takes 0 to 0, but it takes 1 to e power i5 1. Okay. Now I'm not asking you to give me its structure. I'm just telling you that this gate is this. Okay, so finally note down this 5 gate. Okay, ऐसा एक टेबल बनाओ, गेट लिखो, ठीक है, खाली गेट का लिख के यहाँ पे उसके आइगन वेक्टर्स के लिए एक कॉलम छोड़ दो, ठीक है, 1 2 3 4 और सारे गेट लिख लो ऐसे 5, मतलब एक कॉलम आइगन वेक्टर्स के लिए छोड़ देना उनके बगल में. आइगन वेक्टर्स उतना ही इंपॉर्टेंट है गेट्स, ठीक है.
गेट
अभी के लिए सिर्फ 5 गेट लिख लो, ठीक है, एक टेबल बना लो बोल रहा हूँ उसमें, ठीक है, और उसमें 5 गेट लिख लो,
क्या कैसा है?
0 + 1 उसकी हेल्प से देखो। How can we know about it's a 0 and 1 upon √2? Is it,
How do I know that
yeah, how do we know?
that gate takes?
0 cat 0 plus cat 1 upon √2.
Okay. See, the thing is, it is the other way around actually. What do I mean the other way around? I come up with a matrix. मैं एक ऐसा मैट्रिक्स डिजाइन करता हूँ जो कि 0 को 0 + 1/√2 में ही लेके जाएगा। समझ रहे हो? 0 + 1/√2 में लेके जाएगा, मतलब जो 0 को 0 और 1 के सुपर पोजिशन में लेके जाएगा।
Okay.
समझ रहे हो? अब
Position.
उसका फायदा क्या है? उसी फायदे में ही पूरा क्वांटम कंप्यूटेशन का भावार्थ है। The essence of the quantum computing is here. Why did I mention it as the most important gate? I would answer it in a more detail.
सुपर कंपोजिशन स्टेट मतलब एक ही
Superposition
टाइम
state.
सुपरपोजिशन एक ही टाइम पे मतलब 0 भी शो करे 1 भी शो करे, दोनों पॉसिबिलिटीज हो।
It's a little different. I'll just mention it. I'll tell you about superposition idea. अभी के लिए just पांचों गेट को समराइज करके एक जगह पे लिख दो, ठीक है? उनके फॉर्म्स को, ये बहुत इंपॉर्टेंट है, हर जगह तुम्हें लगाने पड़ेंगे क्योंकि इन्हीं को लगा के तुम अपने पेपर करोगे एंड ऑफ द डे, ठीक है?